The main part of Mechanics Homework 5 is about further kinematics. So this is the idea of using calculus and vectors to describe movement. So in question 1 we're given a particle, we're given a mass for it. We're told that there's one single force F that's giving this velocity, and we'll notice this velocity has I and j components that tell us if it's moving horizontally or vertically, or whichever way our axes happen to be, and these both depend on time, so our velocity is going to change with time. As soon as we see time as part of a velocity equation, we can't use suvat, because suvat is for constant acceleration. So in order to find the acceleration of p, we need to know that you need to differentiate velocity in order to find acceleration. So I'm going to take my velocity here and I'm going to differentiate each component with respect to t. So we can write down a, the acceleration, is equal to the derivative with respect to time of v. This is exactly the same as dv by dt, it's just a slightly different way of writing it. This means differentiate v. So if we differentiate v, this one here is going to go to 6t I. So we've gone from a velocity of 3t squared I to an acceleration of 3t I. Notice the I still stays in the same place to tell us that this is in the x-axis. If we differentiate this, we're going to get minus 4, so we're going to get minus 4j. So there is our velocity. So you'll notice this still depends on time, so our acceleration, this still depends on time. We've got some in the I component, some in the j component. Remember to underline these vector coefficients. If we go back to question, or part B of question 1, we're asked to find the magnitude of the force, or the size of the force. We've got acceleration, and we need to find a force, so we should remember that these are linked using F equals ma, where F and m are vectors, so F and a are vectors, and m is just the mass. We get told in the question that m equals 0.5. Putting this in, we get F, the force, equals 0.5 times our acceleration, which is 6t minus 4, with an I in it and a j in it. So putting these together, we get 3t I, and we're going to have minus, we're going to have 2j here. So this here is our expression for the force. We get told in the question that we need to find this when t equals 2, so we're going to write at t equals 2, F, our force, remember this is a vector, is 3 times 2i minus 2j, which comes out at 6i minus 2j. If we go back to the question before we actually write down our final answer, we'll notice we're asked to find the magnitude, so this is the length or size of the vector f. So for this we're going to use Pythagoras, so we get mod f, so the size, magnitude of the force, equals the square root of 6 squared plus 2 squared, which comes out to be square root 36 plus 4, which is square root 40. Because it's mechanics, we're going to write this as a decimal using our calculator, so this comes out to be, so we do square root 40, mode 1, we do square root 40, turn it into a decimal, and we're going to write this down as 6.32 newtons, because it's a force. So remember 3 or 2 significant figures for mechanics, and that's the question done.